Imagine standing on the edge of a vast, fern-covered plain. The air is thick and warm. The ground beneath your feet trembles slightly, not from an earthquake, but from something walking toward you through the trees. Then you see it, a creature the size of a 4-story building, with a neck long enough to look over the roof of your house, pulling leaves from the treetops as casually as you might pluck grapes from a vine. This was the world of the dinosaurs, and it was real. Dinosaurs ruled this planet for over 160 million years. To put that in perspective, modern humans have only been around for roughly 300,000 years. We are newcomers. Dinosaurs were the landlords of Earth for an almost incomprehensibly long stretch of time, and understanding them changes how we see ourselves and the planet we live on. The word dinosaur was coined in 1842 by an English scientist named Richard Owen. It comes from 2 Greek words meaning terrible lizard, though we now know that calling them lizards was a bit of a mistake, and terrible didn't quite do them justice either. Owen was looking at fossils that had been turning up across England, and he realized that certain bones didn't match any creature alive today. They were too big, too different, too strange. He gave them a name, and that name stuck. Before Owen's time, people had been finding dinosaur bones for centuries without knowing what they were. In ancient China, large fossilized bones were believed to be the remains of dragons, and they were ground up and used in traditional medicine. In Europe, people assumed the giant bones belonged to biblical giants or mythical creatures. Nobody imagined that the Earth had once been home to an entirely different cast of animals that no human had ever seen alive. So what exactly makes a dinosaur a dinosaur? This is actually a more interesting question than it sounds. Not every large prehistoric creature was a dinosaur. The flying pterosaurs, the whale-like ichthyosaurs, the long-necked plesiosaurs that lurked in ancient seas, none of these were dinosaurs, even though they lived at the same time. The defining feature of a true dinosaur was the way it stood. Dinosaurs had their legs directly beneath their bodies, the same way humans and horses do today. Most other reptiles have legs that sprawl out to the sides, like a modern lizard or crocodile. This upright posture gave dinosaurs enormous advantages. It let them breathe more easily while moving, sustain higher levels of activity, and grow to sizes that would have been impossible for a sprawling animal. Dinosaurs belonged to a larger group called archosaurs, which also includes modern crocodilians. Within the dinosaur family, scientists divide them into 2 great branches based on the shape of their hip bones. The first group, the saurischians, or lizard-hipped dinosaurs, included both the giant long-necked plant eaters and most of the fearsome meat eaters. The second group, the ornithischians, or bird-hipped dinosaurs, included the armored, plated, horned, and thick-skulled varieties. Interestingly, birds did not evolve from the bird-hipped group. They descended from the lizard-hipped side, which is one of those facts about dinosaurs that sounds wrong the first time you hear it. Dinosaurs first appeared roughly 230 to 240 million years ago during a period called the Triassic. At that time, all of Earth's land masses were joined together in a single giant supercontinent called Pangaea. The earliest dinosaurs were modest creatures, small, quick, 2-legged hunters that shared their world with other reptiles. They were not yet dominant. In fact, for the first several million years of their existence, dinosaurs were far from the most successful animals on land. Other reptile groups held that title. What changed everything was a mass extinction roughly 200 million years ago at the boundary between the Triassic and Jurassic periods. Most of the dinosaurs' main competitors were wiped out. The dinosaurs survived, and with their rivals gone, they spread across the planet and diversified into an extraordinary range of forms. By the time the Jurassic period was in full swing, dinosaurs had become the undisputed rulers of the land. The variety of dinosaurs that evolved over the following tens of millions of years is genuinely staggering. There were tiny feathered hunters the size of crows. There were armored tanks with bony plates running down their backs and spiked tails they could swing like a weapon. There were dinosaurs with frills, crests, domes of solid bone on their heads, and horns arranged in elaborate patterns on their faces. There were dinosaurs that ate nothing but plants, and others that ate nothing but meat, and a good number that ate both. But the ones that tend to capture the imagination most powerfully are the giants, and for good reason. The sauropods, those long-necked plant-eating giants, are the largest land animals that have ever existed. The largest known specimens reached lengths approaching 40 meters. That's longer than 3 city buses parked end to end. Some estimates suggest certain species may have weighed well over 70,000 kilograms. To sustain a body that size, these animals needed to eat almost constantly, and they had evolved remarkable digestive systems to process enormous quantities of low-quality vegetation. How did sauropods get so enormous? Scientists think several factors worked together. Their breathing system was extremely efficient, similar in principle to the air sac system found in modern birds, which allowed them to extract far more oxygen per breath than mammals can. Their bones, though massive, were often hollow, reducing weight while maintaining structural strength. And their sheer size gave them an enormous kind of temperature regulation. A very large body changes temperature much slower than a small one, which meant they didn't need to burn as much energy keeping themselves warm. Of course, where there are enormous plant eaters, there are predators trying to eat them. The meat-eating dinosaurs, the theropods, evolved alongside their prey in an ancient arms race that went on for millions of years. The most famous of these predators is, of course, Tyrannosaurus, which lived at the very end of the dinosaur era and was one of the largest land predators that has ever existed. It had a bite force estimated to be the most powerful of any land animal in history, capable of crushing bone. Its teeth were not just sharp, they were serrated like steak knives and up to 30 centimeters long. But Tyrannosaurus was not the largest meat-eating dinosaur. That title likely belongs to Spinosaurus, a bizarre creature from North Africa that was longer than a T-Rex and spent a significant portion of its life in or near water hunting fish. Spinosaurus had a long, crocodile-like snout, short hind legs, and a spectacular sail or hump running along its back, whose exact purpose is still debated by scientists. There is a popular image of meat-eating dinosaurs as solitary, relentless killing machines, and while many of them certainly were formidable hunters, the reality was probably more complicated. Some smaller theropods may have hunted in groups, though the evidence for true cooperative pack hunting, like wolves, is debated. What is clear is that many theropods were highly active, alert animals with good senses and complex behavior, far from the slow, dim-witted monsters of old movies. One of the most dramatic revisions in our understanding of dinosaurs over the past few decades has been the realization that many of them had feathers, not just the ancestors of birds, but a wide range of theropod dinosaurs, and possibly some from other branches of the family tree as well. We know this because of extraordinary fossil discoveries, particularly from sites in northeastern China, where fine-grained rock has preserved not just bones, but the soft details of skin and feather impressions. These feathered dinosaurs range from small, crow-sized hunters with elaborate plumage to large predators with quill-like structures on their bodies. The feathers likely served multiple purposes at different times in evolutionary history: insulation, display, communication, perhaps gliding. Flight came later, as certain small, feathered theropods began to use their feathered forelimbs to generate lift. This brings us to one of the most remarkable facts in all of natural history. Birds are dinosaurs. Not descended from dinosaurs, not similar to dinosaurs, they are, by scientific definition, a living branch of the dinosaur family tree. When you watch a pigeon pecking at crumbs on a city street, you are watching a dinosaur. When a chicken runs across a farmyard, that is a dinosaur running. There are more than 11,000 living species of birds in the world today, and every single one of them is a dinosaur. The dinosaurs did not go extinct, at least not entirely. They are still here, watching us from telephone wires and rooftops. What were dinosaurs actually like to live alongside? Fossil evidence gives us surprising glimpses into their lives. Many dinosaurs appear to have been highly social animals.
Fossilized trackways show herds of plant-eating dinosaurs moving together, sometimes in groups of hundreds. Nesting sites discovered in Montana revealed that certain dinosaurs cared for their young long after hatching, bringing food to the nest, a behavior we associate more with birds or mammals than with reptiles. Some dinosaurs slept with their heads tucked under their arms, exactly as many modern birds do. Some used stones in their stomachs to help grind up plant material, just as birds use gizzard stones today. Some apparently had elaborate courtship displays, using their crests, frills, and colorful plumage to attract mates, a hypothesis supported by the fact that scientists have now been able to reconstruct the actual colors of some feathered dinosaurs by studying microscopic pigment structures preserved in the fossils. The question of dinosaur intelligence is a fascinating one. For many decades, dinosaurs were assumed to be stupid creatures with tiny brains relative to their bodies. Modern research has painted a more nuanced picture. Brain size relative to body size varied considerably across different dinosaur groups. The small, quick-moving theropods closest to birds had the largest relative brain sizes and were probably the most behaviorally sophisticated. The very largest dinosaurs had proportionally smaller brains, but as with all animals, raw brain size is only one measure of cognitive ability. And then, about 66 million years ago, the world changed. A rock from space, a chunk of asteroid or comet roughly 10 to 15 kilometers wide, struck what is now the Yucatan Peninsula of Mexico at tremendous speed. The impact released energy billions of times greater than any nuclear weapon ever built. It triggered earthquakes, tsunamis, and wildfires across the planet, but the worst was yet to come. In the weeks and months that followed, the impact threw so much debris into the upper atmosphere that sunlight was blocked across much of the Earth. Temperatures plummeted. Without sunlight, plants could not photosynthesize. Without plants, the food chains that supported the giant dinosaurs collapsed. The darkness and cold lasted long enough to drive the non-avian dinosaurs and roughly 76% of all species on Earth to extinction. Volcanoes in what is now India were already erupting massively at this time, pouring greenhouse gases into the atmosphere. Whether this volcanic activity helped cause the extinction, made it worse, or actually slightly cushioned the blow from the impact is still actively debated among scientists. What most researchers agree on is that the asteroid impact was the primary driver of the catastrophe that ended the age of dinosaurs. The birds survived, likely because some of them could eat seeds, which can persist through long periods of cold and darkness. Small mammals also made it through. In the aftermath, these survivors diversified rapidly, filling the ecological roles that the great dinosaurs had left empty. The age of mammals had begun. Human beings have been uncovering dinosaur fossils and trying to make sense of them for almost 2 centuries. The first scientifically described dinosaur fossils were studied in England in the early 1800s. An American dinosaur was formally described in 1858, found in New Jersey, and it sparked a wave of popular enthusiasm that has never really died down.
In the late 19th century, 2 American paleontologists named Edward Drinker Cope and Othniel Charles Marsh became fierce rivals in a frantic race to discover and name new dinosaur species. Their competition, known as the Bone Wars, lasted decades and was marked by sabotage, bribery, and the occasional use of dynamite to excavate fossils quickly. Despite the chaos, their combined discoveries transformed our understanding of dinosaur diversity and gave the world many of its most iconic species. The science of dinosaur research underwent another transformation in the late 1960s and 1970s, when new discoveries and new ways of thinking about the evidence led scientists to completely revise their picture of what dinosaurs were like. The old image, sluggish, cold-blooded, slow-moving lizards that barely managed to drag their tails along the ground, gave way to a new understanding of dinosaurs as active, energetic, often warm-blooded animals with complex behaviors and social structures. This shift is sometimes called the dinosaur renaissance, and its effects are still rippling through the science today. Modern paleontology has tools available to it that earlier scientists could not have imagined. CT scanning allows researchers to peer inside fossils without destroying them, revealing details of brain structure, air passages, and bone growth. Chemical analysis of fossilized bone tissue can reveal how fast different dinosaurs grew, what temperatures their bodies maintained, and even what they ate. In some exceptional cases, traces of soft tissue, blood vessels, proteins, even fragments of what may be ancient DNA have been found preserved inside dinosaur bones. New dinosaur species are still being discovered at a remarkable rate. In the early years of paleontology, a new species might be named every few years. Today, researchers name more than 30 new species every single year, and the pace is accelerating. Major discoveries are coming from places that were little explored in the early days of paleontology: Argentina and Brazil, China, Mongolia, India, Madagascar, and even Antarctica. Each discovery adds to our picture of the extraordinary diversity of life that dinosaurs represented. There is something profound about the story of the dinosaurs. They dominated this planet for longer than any other group of large land animals in the history of life. They evolved into forms of staggering beauty and variety. They developed complex behaviors, cared for their young, communicated with each other, and adapted to every environment the planet offered. And then, through a combination of bad luck and catastrophic circumstance, most of them vanished. But not all of them. The thread of life continued. Those small, feathered, quick-eyed descendants of the great theropods spread across every continent, adapted to every climate, and became the most diverse group of vertebrates on land. Today, they fill our skies with movement and sound. They build intricate nests and sing elaborate songs and navigate continents using built-in magnetic compasses. They are the living link to one of the most remarkable chapters in the history of life on Earth. The next time you see a bird, any bird, take a moment to look at it properly. Look at the scaled feet, which are almost unchanged from the feet of small theropod dinosaurs. Look at the way it holds its body, alert and quick, always watching. Think about the 230 million years of evolutionary history carried in those hollow bones and those sharp eyes. The age of dinosaurs did not end 66 million years ago. It is still going on, right outside your window.